Yeah, good evening all. So before I start, can anyone please confirm whether my voice is clear, whether the screen is visible or not? Yes. Thank you. So in the last class yesterday, I was just briefing you about what is big data, why Hadoop, drawbacks with the current databases, Hadoop and Hadoop advantages, Hadoop job market, Hadoop and PySpark job market. Yes. So just let us have a quick review what we have discussed. Yes. Big data, huge volumes of data, right? We have got databases like Oracle, MySQL, and specialized databases. Databases and specialized databases, they can handle data up to some extent. But for huge data, unlimited data storage, right? For unlimited data storage, right? Unlimited data processing, right? We have got a framework called Hadoop, which is meant for both storing and processing. For storing, it uses HDFS, Hadoop Distributed File System, and for processing, MapReduce or Spark it is using, right? Hadoop is mainly meant for batch applications. It's not for online applications. User, there are two types of applications, online and batch application. User interactive applications, we call it like online applications. Here user gives the input, booking a movie ticket, transferring the amount through online, right? So here user gives the input, user is required. Here user non-interactive applications. Here user is no way required, user is no way required. Railway ticketing PNR status, generating credit card statements for millions of customer, right? Yes. So Hadoop can perform both storage and here, what are the drawbacks with the current databases? Drawbacks with current databases, limited storage, you can see, limited storage, no parallel processing in most of the databases. If volume increasing, speed decreases, right? If volume increases, speed decreases. Select total amount from sales 1, 10 records. Select the total amount from sales 2, 1 lakh records. Total amount from sales 3, 1 crore records. So here is volume increasing, right? As volume is increasing, speed decreases. Here you can see, right? Here, query to query, query to query. As volume increases, speed decreases. As volume increases, speed decreases, right? Yes. If complexity increases, speed decreases, right? Complexity means total amount from sales 1, average amount, right? Total amount, average amount, standard deviation of amount, right? So if you see query to query, right? As volume increasing, sorry, as complexity increasing, right? So average amount is a two-step process as compared to the total. Yeah, it takes more time and standard deviation, lot of internal processing required. Yes. Databases can handle only structured data. They cannot handle unstructured or semi-structured data. Yes. So Hadoop can handle all varieties of data. Hadoop can handle all varieties of data, structured, unstructured, and semi-structured. So before I go with advantages of Hadoop, so you need to know something about this Hadoop, right? Architecture. So I'll just give an overview as of now. Later I discuss in brief like storage architecture and processing architecture. Hadoop follows Hadoop follows master slave architecture. Hadoop follows See here, Hadoop doesn't follow client server, right? Hadoop doesn't follow client server architecture. It doesn't follow client server. It follows master slave architecture, right? It follows master slave architecture, single master and multiple slaves. Hadoop, what do you mean by Hadoop cluster? Hadoop cluster, group of nodes. Group of nodes connected in a network. Group of nodes connected in a network. Group of nodes connected in a network. There are two types of nodes. One second. Okay. A group of nodes connected in a network. There are two types of nodes, right? Yes. Okay. Just observe. Right. This is single master, multiple slaves. Single master and multiple slaves. S1, S2, S3, or SN you can say. So on up to SN. This is the master node. We say this as master node. So this group of systems, group of nodes. Nodes means systems, CPUs. Group of systems connected in a network. The one will be the master and the remaining all will be the slave nodes. All this we call it like a cluster. And this we call it like slave nodes. In Hadoop terminology, master node call it like name node. Within that we see like name node, and within this slave nodes say like data nodes. Master node we say like name node, NAME. Slave nodes we call like data nodes. Why data nodes? Because data is stored by the slaves, data is processed by the slaves. Data stored by the slaves and data processed by the slaves. Okay. Hadoop follows master slave architecture, single master and multiple slaves. Yes. Data is stored by the slaves, data processed by the slaves. For example, in Hadoop, data is stored in the form of files, txt files, assume right, f1.txt. Assume that if you got 2 TB of data. Here it has got 1 TB, 1 TB, 1 TB. Hard disk capacity is 1 TB, 1 TB, 1 TB. This 2 TB file cannot fit into any of this system, right? It cannot fit into any of the system, right? So in Hadoop, this whatever this data object, data set, it will be splitted into smaller parts. It is splitted into smaller parts. Data is split into smaller parts. Each part is stored. So first part in system 1, second in system 2, third each. So it divided into multiple partitions that we call like blocks. So the data will be split into smaller part. Each part will be stored across multiple systems. Okay. So data is distributed. Two advantages we see here. Data is distributed across the multiple systems and data is processed by multiple systems parallelly. Data is stored across multiple systems and data is processed by multiple systems parallelly, right? So distributed storage you can see and parallel processing, right? So okay. So everything done by the slave nodes. Data storage is done by the slave nodes. Data is processed by the slave nodes. What the master node does? Master nodes allocates the task T1 task to S1, T2 task to S2, T3 task to S3. Master node allocates. So it allocates T1 task to S1, T2 task to S2, T3. Just who is allocating the task? Master. Who is executing the task? Slaves. So slave nodes executes the tasks. Yes. So there are two types of nodes. There are two types of nodes. First is like master node, name node. So like name node, slave node or data node. Master node responsibilities. Master node responsibilities. Master node responsibilities. First one, task assignment, load balancing, fault tolerance. Observe here, master node responsibilities, assigning task, load balancing, fault tolerance, and health monitoring, right? Health monitoring. Yes. Master node assigns tasks to the slaves. Slave node has to execute the tasks. Load balancing. The task should be equally given to all the slaves, right? And fault tolerance if multiple tasks are executed by multiple slaves parallelly. So here T1, T2, T3, three tasks are executed by the three slaves parallelly. If any one slave goes down, if any one slave goes down, if any one slave goes down, then the task of that slave should be assigned to any of the other slaves that is taken care by the master node. If multiple tasks are executed by multiple slaves, if any slave, if
Yes, sir.
any system goes down, then the task of it has to be assigned to any of the available slave, that is system, right? That is done by master node. Yeah, any query you got?
Hello, sir.
Yes.
So data duplicacy is not there in this name node. Is
In
in the term the let's 2 TB of data is there, and we have a page size of 20 KB is storing in the name node. So each individual name node have a only 20 KB, or there is a some duplicacy is maintained for the failure region.
See here, in the case of name node, there is no kind of duplication. It just maintains the metadata information. Da data about data, it just maintains the metadata, the files information will be maintained. So total data, everything will be stored within the data node, that is slave nodes.
Let's suppose
Slave nodes only are going to store, and the slave nodes only going to process the data. Name node or master node, it just maintains the metadata information of a particular file or data set. The actual data will be stored by slave node, data node, right?
uh,
And what are the responsibilities of master node is assigning the tasks, balancing the load of the and fault tolerance. In the absence of any slave fails, immediately the task has to be assigned to any of the other slave, taken care by master node. Health monitoring before assigning a task to a particular slave.
so how they can monitor? Let's suppose node N1 has given a task, and by processing it has to process 20 KB of data, but after processing of 5 KB the node got failed. How it's node master node that it has processed that much of task, or whole task is assigned to the new one?
So here, okay, this is the master, these are the slaves. Master and slave architecture. It follows master and slave, S1, S2, S3. Okay, master node. So here internally we got some other processing components are available. Job tracker, task tracker will be the job tracker assigns the task tracker executes the task. Later I discuss about this. But as of now, right? So here T1 task to this, T2 task to this, three tasks assigned to the three systems. They're executing parallelly as they are machines, they are systems. If any system goes down, then any one of that slave, if any S4 is available, that will be assigned to S4. If S4 not, if S4 not available, S1 or S3 need to perform two tasks. If any slave is already available, it's free to assign to that. And your query is, while executing T2,
Yeah.
20% of the task execution is completed by T2.
Yes.
Once that it is failed, once that T2 task is failed, so the same. So here, one second, you need to understand two things here. Here you got some data, f1.txt. File is divided into blocks here. B1 block, B2, B3. Partitions, B1 stored here, B2 stored here, B3 stored here. B1 has got 10 lakh records, B2 has got 10 lakh records, B3 has got 10 lakh records. This 10 lakh records of B2, once the system is failed, the B2 data is lost here. 10 lakh records are lost.
Yes.
10 lakh
Yes.
records data is lost. And
Yes. Yes.
T2 task is failed, means entire job also fails.
Yes.
When job is successfully executed means all the three tasks are executed successfully, then only the job is successful. So here you see two things: data is lost and the task is failed, job is failed. So how
Okay.
Hadoop is going to overcome this kind of? It is coming with a concept called a replication and fault tolerance.
Replication.
Replication and fault tolerance, right? Yes. Replication for data loss, it will be overcome it, and fault tolerance for the task failure, right? Yeah. Okay. So I'll be just briefing. We have got a lot of discussion on this replication fault tolerance. I'll be briefing you about it. So there won't be any data loss. There won't be any task failure or job failure using this replication and fault tolerance. Fault tolerance means the task will be assigned to any of the other slave by the master node. There will be heartbeat signals. There will be some heartbeat signal. How you may ask, how can this master node comes to know that particular S2 is down? Then only it can assign the task to any other slave, right?
Yes.
How the master node comes to know that particular system S2 is down? Then only the T2 task can be assigned to S4 or any other, right? So there will be some heartbeat signal between the master and slaves. If the heartbeat signals are missing, then master node thinks that a particular slave is down. For example, you are getting signals from S1 and S3. From S2, there are no signals coming to master node. Then immediately master node thinks that S2 is down. Immediately it will assign the task to the another slave. So based on the heartbeat signals. Okay. So in the architectural part, I'll be discussing all this. Storage architecture, processing architecture, and health monitoring. Before assigning any task to a particular system or slave, master node will have the entire health status of each and every system. So before assigning the task, what is the health status? If that system is fine, then only the task will be assigned, right? So health monitoring, fault tolerance, load balancing, task assignment, master node responsibilities. Slave node responsibilities are two. Slave node responsibilities. Slave node responsibility, right? Storing data and processing data. Storing data and processing data. Okay, fine. So there are two types of nodes, master and slave, that is name node and data node here. Master node for assigning tasks, for fault tolerance, for health monitoring, for load balancing. Slave node for storing and processing. And now coming to this Hadoop advantages. Unlimited data storage. Unlimited data storage because of a feature. Horizontally unlimited scalability. Horizontally, yes. Horizontally unlimited scalability, right? Yes. Yes. Horizontally unlimited scalability. Horizontally unlimited number of slaves can be added. What do you mean? How unlimited data storage? Unlimited data storage is possible. Yes. Unlimited data because of a feature. Horizontally unlimited scalability. Horizontally unlimited scalability. Right? Yes. So if you are running a business with very less number of slaves, uh, S1, S2, so 10, you have got 10 systems or 10 slaves. If your business has increased, if your branches have increased, customers have increased, means data also increased. So also you need to increase the number of slaves horizontally. Horizontally, the number of slaves has to be increased. Okay. So any number of slaves can be added. If data is increasing, the number of slave systems also increase horizontally, right? Very high speed processing because of parallel processing. Because of parallel processing, right? Yes. Yeah. A labor example. A labor example, right? Yes. Non-parallel and parallel. Non-parallel and parallel. One person preparing one item takes 1 minute. The same one person preparing 10 items takes 10 minutes. The same one person preparing 100 items takes 100 minutes. The same one person preparing 1,000 items taking 1,000 minutes. One person preparing one item, 1 minute. One person preparing 10 items, 10 minutes. One person 100 items, 1,000 items, 1,000 minutes. Right? Yes. Okay. But in the case of parallel, one item, 1 minute only. 10 items, 1 minute. 100 items, 1 minute. 1,000 items, 1 minute. So here, 10 persons preparing 10 items takes 1 minute. 100 persons preparing 100 items, 1 minute. 1,000 persons preparing 1,000 items, 1 minute. Here we say persons, but in our case, we say like systems. Multiple systems running parallelly, right? Can handle all varieties of data, structured data, unstructured, and semi-structured data. Can handle all varieties of data, right? Commodity hardware. It can run on any hardware. Doesn't mean that you need to have very high configured hardware. No, it can run on any hardware, right? Yes. No licensing required. No licensing required, right? Yes. Most of these are from Apache, right? Apache products. Can Apache Mirror's website, you can download and you can use it, right? And I was saying, right, mm, Yahoo has taken a table of 100 TB consisting of 1024 columns. Task is sorting based on 16 columns. Sorting based on 16 columns, right? Time taken by different databases. So Oracle has taken 3.5 days. MySQL has taken 6 days. Teradata has taken 4.5 hours. Netezza has taken 3 hours. Netezza has taken 3 hours, right? Hadoop has taken 3.2 minutes. The Hadoop has taken 1.4 minutes. Yes. This is the speed of Hadoop as compared with other things, right? Where it has taken days of time, hours of time. Hadoop has taken minutes of time. Very high speed processing because of parallel processing. And that is Hadoop is proven processing point of view, not only processing point of view, storage point of view also, right? I have got a query. Why databases like Oracle? See this, why databases like Oracle cannot store, why databases like Oracle cannot store unlimited data, cannot store unlimited data. Huge data, unlimited data, right? So if you talk about these databases, for databases also, they can go with multiple slaves in real time, right? Talk about these databases and their limitations on max number of slaves, max number of slaves, databases and max number of slaves. databases and max number of slaves. Databases like Oracle. Oracle also can go with number of slaves. Maximum Oracle can go with max of 256, 256 slaves. Systems, CPUs. Slaves means CPUs, systems. MySQL, right? Yes, can go with max of 54 slaves. Once the 54 slaves gets filled, they cannot support data further. But MySQL Express, we have got MySQL. Express, it can go with maximum of 256 slaves. Sorry, MySQL. SQL Server can go with max of 256 systems. DB2 also can go with maximum of 256. Beyond that, they cannot, just like that. So even if this 256 slaves gets filled, the performance of the system degrades. Just like a labor
There are two MySQL. One is MySQL and one is MySQL EXP.
Express.
Okay.
MySQL Express can go with 256, right? So even if I was talking, right, if this talking about this Oracle, if this 256 slaves gets filled, the performance of the system degrades, just like your mobile phone. If 64 GB internal storage is given, if entire 64 GB is filled, the performance of your phone degrades, right? Sometimes it won't even start. Same way here also, once the data gets filled, it cannot support data further and the performance of the system degrades. If you talk about the specialized databases, like Teradata, which can store TBs of data, right? It can go with 512, right? 512 slabs. Even Netija is another specialized database used for data warehouse purpose, right? It also can go with 512 slabs. And also like Vertica, they can also go with 512. So beyond that, okay, but currently Teradata is supporting 1024 slaves. Even Netija also supporting 1024. But even though if you get that 2024 slaves are CPUs, still it's limited storage. It cannot go with unlimited. Once they get filled, they cannot support data further, right? So if you talk about the database or specialized database, none of these they allow like unlimited data storage. They are used for OLTP, online transactional processing. Uh, but but there is no limitation. There is no limitation on the number of slaves. On the number of slaves that Hadoop can have. Hadoop can have, right? Unlimited, horizontally, unlimited scalability, horizontally unlimited number of slaves can be added, right? Yahoo, when first time implemented Hadoop, Yahoo, when first time implemented Hadoop, Yahoo, when first time implemented Hadoop, went with, so, okay, 4,000 slaves. Yahoo, when first time implemented Hadoop, went with, currently Yahoo going with 12,000 slaves. Facebook, when first time implemented Hadoop, When first time implemented, Hadoop went with 8,000 slaves. 8,000 slaves. Currently, Facebook going with 42,000 slaves. That is not like 256 or 1024. Now, yes, Hadoop can go with unlimited number of slaves, 4,000 slaves, 12,000, 8,000 or 42,000 of slaves. There is no limit on the number of slaves Hadoop can have. So Hadoop is prevent storage point of view, processing point of view with a very high rate of speed, right? Yes. Hadoop ecosystem components, like we are going with HDFS, MapReduce. HDFS is for storage. MapReduce is for processing. Hive is also meant for processing. We use a language called HQL, which is similar to SQL, right? Scoop for SQL and Hadoop, right? Yes. Import or export operation. One second. Hadoop ecosystem components, HDFS for storage, MapReduce for processing, Hive also meant for processing. Here we use a language called HQL, similar to SQL for data warehouse kind of environment within the Hadoop framework. Scoop is for importing or exporting data from different databases to Hadoop and Hadoop to databases, import or export. NoSQL databases, schemaless behavior and random access. So schemaless in normal SQL, we have got schema first record to last record, same number of fields to be maintained. But here record to record, different number of fields can be maintained. HBase is one of the NoSQL database I'm going to discuss. And also like Cassandra also I'll be discussing in PySpark. Yarn, yet another resource negotiator. Zookeeper controls and coordinates all the Hadoop components. Flink Kafka for live streaming data. Means
Yes.
yes.
So Cassandra, you are explaining with HBase or it's a separate one?
So yes, 1 second. NoSQL databases, we have got many NoSQL databases.
One is MongoDB, another one is
1 second, 1 second. NoSQL databases, HBase is one. Cassandra, MongoDB, HouseDB, React, Peanut, Neo4j. It is where many NoSQL databases. Among that, HBase is which uses, it's a Hadoop database. HBase is used for this Hadoop environment, where HBase uses HDFS itself, right? H for data modeling elements. So that's why I'm discussing HBase, right? As part of one of the once you know SQL database as part of this course, I'll be discussing like the three processing components like MapReduce, Hive, and PySpark, three processing and one storage component HDFS, and one NoSQL database HBase, and also give some knowledge on this Cassandra set, and two streaming components like Flink Kafka. Two streaming components, NoSQL database, three processing components, and two streaming data for live streaming data, right? With like Flume and Kafka. And in PySpark, in brief, we'll be discussing on PySpark, Spark Core, SQL, Spark Streaming, and Spark ML machine learning library. Yes, this is what this entire that what we are going to discuss, right? So as I said, you'll be getting the session video on daily basis, soft copy of these notes, assignments and task work, and WhatsApp group for technical discussion, right? So just I'll pardon.
One more question. What is Apache Flink then? It's also a processing engine or what type of?
See, yes, 1 second. Flink is there, right? Flink.
Yeah.
It is also an Apache product. Like Spark is also Apache product. Flink is also. So if we Spark was first, a Spark was introduced by Apache.
Okay.
Spark was introduced by Apache. Later, Apache introduced Flink. In 2016-17, when the boom for Spark has started, right? Immediately when the boom for Spark has started, immediately Apache started introduced Flink also.
Okay.
So it also introduced both purpose, objective and the purpose is same. Spark and Flink, both the objective and the purpose is same, right? But immediately people who already working on Spark, who operated with Spark, they were saying that Flink is dominating Spark and Spark will be away from the market. It was true. Flink was dominating Spark. Um, so later Spark has come with powerful libraries. Spark has come with powerful libraries which dominated Flink. So in the initial versions of Spark, Spark was weaker. That is Spark or PySpark, what I say. It was weaker in the case of data analytics, machine learning libraries, right? But for streaming and for graph algorithms, Spark was weaker. See, there is a version Spark 1.6. Before this version, before this Spark 1.6 version, before Spark 1.6 version, Spark Flink was dominating. Spark was weaker as compared to Flink. From Spark from Spark 1.6 onwards, right? Spark came with powerful libraries. It almost was equal to Flink. And from Spark 2 version onwards, many libraries were introduced. It has come with powerful libraries from Spark 2.0 onwards, right? Totally Spark has dominated Flink. Spark has dominated. Like now you won't see that mostly Spark and PySpark you'll hear, but not Flink. Previously Flink was dominating, but slowly what Spark has introduced many libraries, right? Towards graph algorithms, for streaming, information learning libraries, it has introduced, and it is totally dominating Flink. And okay, Spark, it's a very high-speed processing, in-memory computation. One Spark income. See, Spark. I'll be discussing this Spark, PySpark, right, as part of this course. See this. Just now I was discussing Spark. Hadoop takes just 3.2 minutes or 1.4 minutes, right? As compared with other databases like Teradata and Etija taking hours and days. Hadoop is taken just 1.4 minutes. But Spark, very high speed processing, right? Very high speed processing. Then already Hadoop has taken very less time. But Spark 100 times faster than Hadoop. 100 times faster than Hadoop. So that's why today, like Hadoop and Spark, both are used in the market. So for storage, we go for Hadoop, and for processing, we like go for Spark. So that's why I said here, Hadoop is meant for both
There is
storage, HDFS, for processing, MapReduce Spark. MapReduce Spark, right, for processing, very high speed processing. So, but the company is using a Spark, that is PySpark, right? So we need to maintain huge RAMs. Means data is going to fit into the RAMs and data is processed within the RAMs. RAM level storage, not in the disk level storage in Spark. In-memory computation. In-memory means memory level computation, right? So they will be stored in the memory and processed in the memory. That's why huge RAMs has to be maintained. When you are able to afford huge RAMs, you can go with Spark technology. So the companies like, no, I want speed, very high speed. I want in very quick time, then go for Spark. Otherwise, companies using Hadoop, if they are unable to maintain huge RAMs, Hadoop is preferred. And Hadoop, not only for that, there are some components of Hadoop which are mostly preferred, right? Like Scoop, Hive, uh, and NoSQL databases. Apart from this, and if you doesn't maintain huge RAMs, Hadoop is better choice, right? Both Hadoop and Spark, both. That's what I'll be discussing. 60% of our time I will be spending for Spark, 40% for this Hadoop components, right? That's and how this storage and how this processing is happening within the Spark. Spark, I said Spark can be coded with multiple languages, with Python, Scala, Java. Java is very less preferred. Java is very less preferred, not at all preferred. Only company. Value Labs, companies like Value Lab is preferring Spark with Java. Remaining all other companies, PySpark, Spark with Python, PySpark. And Spark with Scala is also preferred. But as now, Python has got a high boom, right? Because of this ML machine learning libraries. So Spark with Python, PySpark is mostly preferred. Yeah. Just I'll give some overview as of now as per related to this PySpark. Spark or PySpark, you will get some understanding why the usage of. So if you take what is Apache Spark, just I'll take 10-15 minutes. Apache Spark. Why PySpark? If you say why PySpark, need for PySpark. Need for PySpark. PySpark features and real life usage of PySpark. Real life usage of PySpark. Okay. Apache Spark, right? Yes. Apache Spark. It is an open source. It is also open source. It is also like Hadoop. It's distributed. Cluster computed. It is also like cluster computing technology, right? It's a framework. And in-memory computing has got in-memory. One more feature which you won't see in Hadoop is in-memory computation with memory level, right? Memory level storage and memory level processing, right? Yes, very high speed. And why? So I can say Apache Spark, it's a general engine for big data analysis, processing, and computation. Why PySpark? It's a Python API. PySpark is what? A Python API. Python API, right? To use Spark. Python API to use Spark. PySpark is one of API of Python, right? To use Spark. Spark, okay, I said it's an open source cluster and PySpark is a lightning fast technology, right? It is designed for fast computation. It is a very demanding tool, right, for data engineers today to work with bigger data sets. So PySpark used for distributed SQL, for creating data pipelines, and for ingesting data into databases, for running ML algorithms, working with the graphs and data streams, right? For all this. And if you see the need for PySpark means today if you see huge data is getting generated everywhere through online or through offline, right? The data is containing hidden patterns, unknown corrections, market trends, customer preferences, and other useful information, right? So we need to extract only the required data from that raw data, right? So we require a efficient tool from a huge data. If you want to just extract the valuable data or required data, right? We need to have some efficient tool for performing those type of operations and huge data and big data, right? So already we have got some tools already available, but they are not that much of appealing, right? So we need some flexible tools to crack a big data, to crack that big data and gain benefit from it. So PySpark is such a kind of technology at a very high rate of speed. That is combining Python and Spark would be the efficient way for the world of big data. That's why Apache Spark community came up with a technology like with a framework called PySpark. It is Python API to use Spark, right? Yes. So we have got many features for PySpark that I'll be discussing during the course. But as of real life usage, also if you see today, PySpark is preferred a lot in real life use cases. For example, for commercial sector, right? For real time processing, immediately if any fraud occurs, right? Immediately, right? Real time processing systems. Bank and other financial fields, they are using PySpark to retrieve the customer's social media profile and analyzing the useful insights from it to taking the right decisions, whether to give loan to a particular customer or not, for credit risk assessments, for fraud detections. Even it is PySpark used for healthcare, right? Even PySpark is preferred in healthcare in analyzing patients' records along with their previous medical history and which patient is going to face an issue if even after being discharged from the clinic, right? So that kind of predictions analysis can be done, right? And even PySpark is also used in the entertainment industry. The major, like today, if you see the OTT platform, the popular OTT platform, Netflix, right? Using this PySpark for real-time processing for this online movies and web series, right? It is processing nearly 450 billion events per day. They are streamed over server-side applications, right? Even this Netflix using this PySpark, and even for this trade and e-commerce, right? Like Flipkart, Amazon, they are using PySpark for advertising, right? Provides enhanced customer experience even for kind of recommendations, right? People who are purchasing a particular product also, many are they are purchasing the other recommending, right? If you are purchasing this, they also purchase the other products, right? That kind of recommendation systems implemented using this PySpark. And for tourism industry also, right, where PySpark advising millions of travelers by comparing the uh, and advising the travelers, right, by comparing the hundreds of tourism websites, right? So in brief, we'll be discussing about, and if we can see that course content, right? Yes, of both Hadoop and PySpark, what is discussed, what is what is big data, need for Hadoop, sources, storage and processing, HDFS, name node, data node, uh, about related to the cluster, right? Metadata management, storage and processing, map reduce processing, yes, and the scoop for import or export operations, performing various operations during import before data is imported to HDFS, performing filtering, grouping, aggregations, joins, right? Yarn, yet another resource negotiator, yarn architecture, yarn components, how the processing is going to happen internally, which you are not able to see that, right? And NoSQL database, different NoSQL databases, the differences. And HBase is one NoSQL database. In brief, we'll be discussing creating the tables, CRUD operations. Hive is one of the important, Hive is the important component of Hadoop. We have got only jobs in Hive. We will be discussing a lot on this Hive, where we create internal and external tables. And we use a language called HQL and loading data from local files, HDFS files, internal tables, external tables, working with unstructured data, XML data, JSON data, URL weblog data, joins, and UDF, UDAF, UDTF, right? User defined functions, aggregated functions, tabular functions, non-partition, partitioned, static partition, multi-column partitioning, dynamic partitioning, performance tuning, bucketing, indexings, and Hive and HBase integration. Coming to PySpark in brief, right? Yes. So Apache PySpark sessions, context, parallelizing, repartitioning, broadcast variables, accumulators, operations on RTD actions, transformations, persistence features, memory options, disk options, PySpark core computations, fault tolerance models, groupings and aggregations, single grouping, multi-grouping, multiple aggregations, various actions and transformations, count by key, count by value, zip, union, distinct, inner join, and various the PySpark SQL data frames and various data frame APIs one by one in brief. So struct type row class select collect with column renamed drop union UDF map flat map for each one by one inbuilt functionality with working examples. PySpark SQL functions, aggregated functions, window functions, date and timestamp functions. No need to write huge codings here. Many inbuilt functions available, right, to perform those. Even PySpark built-in functions when lit, split, translate, overlay, to date, month, array, collect, create. So all this, right, in brief will be discussed. And PySpark external sources with Hive integration, MySQL integration, transformations, wide, narrow, and wide transformations, handling nulls, writing data back to external sources, deployment modes, local mode, cluster mode, PySpark applications, stages and task, driver and executions, building Spark applications, deploying PySpark apps to cluster and tuning. Yes. PySpark streaming components, integration with Kafka. Yes. And people who choose with Python package, right? With Python also, this with Python package, without Python, right? There are two things. So if you are choosing Python also, yes. Python basics, Python operations, data types, constants, variables, escape sequences, operators, IDs, flow control statements, looping, strings, collections, lists, tuples, sets, dictionaries, functions, modules, packages, errors and exceptions, file handling, object-oriented programming concepts, regular expressions, database connectivity, date time related operating system, advanced concepts, iterator generator closures, working with CXC, XML, JSON files, graphic, and working with Excel files, data analytics, working introduction to data science, pandas module in brief, NumPy, numerical Python in brief, right? And matplotlib in brief, right? Yes. 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 No. So Hadoop, PySpark, Spark with Python, right? Everything Linux and Python. So this will be discussed on this weekends, right? Saturday 2 hours, Sunday 2 hours, right? Totally 4 to 5 hours, right, per week. And this Python, as I said, Monday to Friday, you can attend. If you choose the fee structure for this is 15,000, where Hadoop will be covered, PySpark, Linux, and Python. These four courses will be covered, right? It's an offer batch. See this Python nearly for you'll be learning like 2 months of Python course, 1.5 months to 2 months, right? It takes 1.5 months to 2 months for this Python core in advanced, Monday to Friday. Okay. So morning or evening, right? You can attend if either you can attend live sessions or you can go through the videos of the daily will be going. You're not unable to attend. So morning 5 a.m. right? And evening 7 p.m. There are two batches for Python. For the first 1 week, it will be at 5 a.m. right? But later it starts at 6 a.m. in the morning up to the end of the course. And here also for first 1 week, it will be at 7 p.m. Later it will start at 8 p.m. right? For those who wants to go for Python. And without Python, right? Just if you want to go Hadoop, Python, and Linux, right? The fee structure is 12K, right? So as I said, the offerings, you'll be getting the every session video of Hadoop, PySpark, Linux, and Python, right? Right. Notes, soft copy of the notes, right? And every videos you'll be getting to your Google Drives, notes to your mail IDs, assignments tasks, and WhatsApp group will be created, right, for technical discussions. So next Saturday we'll be going with we'll be entering. Just I will be discussing about this. Will be an actual subject. We'll enter into the actual subject. How exactly the storage and processing happening, right? Yes. So next week I'll be briefing you about the software. I'll be demonstrating about the software. I'll be providing the software to your Google Drives, and I'll be showing you how to execute in different environments, right? So you need to get enrolled, right? You need to get enrolled for getting the next Saturday's link. If you want to get next Saturday, the link will be changing, right? So you need to get enrolled for getting the link to your mail ID. And next Saturday onwards, you'll be getting the videos to your Google Drive. Yesterday's and today's video, and the next upcoming videos, everything you'll be getting every day one video will be added to your Google Drive. Notes, you'll be getting clear notes of what we discussed, right, to your mail ID or into your WhatsApp group. And next Saturday there will be a WhatsApp group created for the enrolled students. You can see in the chart, right? And you can see the chart about the payment procedure, right? Through Google Pay or Phone Pay. The online team has forwarded a message related to the payments, and they have given the contact details for any queries related to this piece, and also the course structure. Uh, yes. Okay. So any other queries, right? So next week onwards, we'll be starting with that actual technical part. Any other queries? So I said the sessions will be interactive sessions. You can ask queries at any part of time during the session. You can type in the chat. There won't be any theoretical. Everything will be practical. I'll be showing you step by step, line by line, right? Everything I'll be showing you step by step. Yes. As Python, the coding goes in Python. Python is a interact. It is. It's not like compilation language. It is interpretation language, where line by line execution is going to happen, right? For every line, you see the response, right? So a line by line, what is the output? And also Spark, PySpark, the data flow language, means the output of it will be taken as input to the next flow. In this way, the output of it will be taken to the input of the next flow. Yes. Fine. Any other queries, anyone? Okay, fine. So I'm stopping here. We'll continue next week, right? So just introduction to Hadoop and PySpark, what we are going to discuss, how this training goes. And I said the Hadoop PySpark, the course duration is like 12 weeks. 12 weeks, right? It goes total in brief. We'll be discussing, if you see the course content also, everything will be discussed in brief, right? I said I'll be giving knowledge on streaming technologies, NoSQL databases, processing components, storage components, right? Yes. Fine. So, okay, I'm signing off for now. Thank you all for your time. Thank you. Meet you next week, right?